Max. In this video, we will solve a problem asked in CSIR Net June 2023 in Part B, the question ID 704047. This question is related to integral equations. So here we are given a boundary value problem y double dash of x plus 2y of x equal to 0 with the condition y of 0 equal to 0 and y of 1 equal to 0. So from this differential equation, so we need to find the corresponding integral equation, which is the form y of x equal to 2 times integral 0 to 1 k of x comma t y of t dt, where k of x comma t is the kernel. So we need to find the kernel for the given problem or for the given differential equation by converting it into an integral equation. So we are given a differential equation. It is second order differential equation. Therefore, so we will differentiate or integrate this with respect to x between the limits 0 to x to obtain an integral equation. So when you differentiate once y double dash of x plus 2 times y of x, so this is integral between 0 to x dx equal to 0. We can take some other variable t. So when we integrate, so we will get y dash of t. So the limit is 0 to x, and this one plus 2 times integral 0 to x y of t dt. So this one is equal to 0. So substituting the limits, upper limit minus lower limit, so get y dash of x minus y dash of 0. So this is equal to minus 2 times integral 0 to x y of t dt. So now we need to integrate once again. So between the limits 0 to x, so here we will get y of x minus y of 0 minus, so x times this one. So integrating this, we will get y of x, the limit is 0 to x, so this is y of t and minus, so x times y of 0, so the limit is 0 to x equal to minus 2 times integral 0 to x so y of t dt to dt1. So here we will get y of x minus y of 0 minus x times y of 0. So here we can use the formula for the term on the right hand side. So this is equal to minus 2 times integral 0 to x minus t y of t dt. So we have the value for y of 0. So y of 0 is 0. So therefore y of x minus x times y dash of 0 equal to minus 2 times integral 0 to x minus t y of t dt. So we need to find y dash of 0. So for that, so substitute x is equal to 1 because we have the value for y of 1. So y of 1 minus y dash of 0 is equal to 2 times or minus 2 times integral 0 to 1. So x is equal to 1, therefore 1 minus t y of t dt. So we have the value for y of 1. What is y of 1? Y of 1 is 0. So y of 1 is 0 here, therefore 0 minus y dash of 0 equal to minus 2 times 0 to 1, 1 minus t y of t dt. Therefore y dash of 0 equal to 2 times integral 0 to 1, 1 minus t y of t dt. So this is our equation 2. So we can make this as equation 1. So now substituting equation 2 in 1, now 2 in 1 implies y of x minus, so x times y of 0, so you will get so multiplying this by, so minus 2 times integral 0 to 1, so x times 1 minus t y of t dt, this is equal to minus 2 times integral 0 to x, x minus t y of t dt. So we need to find the integral equation of this form, y of x equal to, so this one. So we will get, so this can be the second term, we can make it to the right hand side. So 2 times integral 0 to 1 x times 1 minus t y of t dt minus 2 times integral 0 to x, x minus t y of t dt. So this term can be written as, so we have 2 common, so 0 to x, x times one minus t y of t dt plus integral x to 1 x times 1 minus t y of t dt, and the second term can keep as it is, 0 to x, x minus t y of t dt. So this is equal to 2 times, we can combine the first term and the third term, so this one and this one. So we have 0 to x, so x minus xt, so y of t is common here, so here we have minus x plus t y of t dt, and third term will be as it is, x times 1 minus t y of t dt. So this is equal to 2 times integral 0 to x, so these two will be cancelled, so we can take this t 1 minus x y of t dt plus this term integral x to 1 x 1 minus t y of t dt. So therefore, so this is kernel 2 times integral 0 to 1 k of x comma t y of t dt. So what is k? K is the kernel, so t times 1 minus x when this t lies between 0 and x, and x times 1 minus t when this t lies between x and 1. So now we can check the correct options. So according to our answer, the option A is correct, so the rest of the options are wrong. So if you like the content of this video, kindly like and share with your friends, also subscribe our channel. Thank you.